All right, my friends, welcome back to graphing in the polar coordinate system. We're going to move on to our next family of polar graphs. So for example 5, let's have you look at, if I ask you to graph r equals 2 times sine of 3 theta. So really quick, I just want you to take a look at this and ask yourself, what about this equation makes it so that it is not a circle? And I hope you can see it's the 3 there that makes it so this won't be a circle. And then I hope it's pretty clear that it's also not a spiral. So we're dealing with something of a new type of polar curve. So whenever you have a new type, and this is something that if we were in school, I would have had you do, grab a partner and do whiteboards and windows and just kind of, discover it yourselves. Sadly, we won't be doing that. So instead, we're going to go through a t-table, and you will find that this is the one type of polar curve. I think you're going to find it pretty quickly here in a second. It's the one type of polar curve that I do not do t-tables for. And as we do this little t-table, and it's really just meant for discovery purposes, so that things that I tell you pretty soon about other ways to do it will actually feel true, because you will have had this kind of organic t-table type experience with it. But yeah, like you can probably see by the theta values that I'm choosing that that the t-table approach is probably not going to be our favorite thing for this type of a graph. Okay, just to give you an idea as to why I chose these angle measures, I basically chose anything that when I put it in for theta and I triple it, I get something that's unit circle friendly. So for example, pi over 18. If I put this in for theta, then I have to multiply it by 3 and I get pi over 6. Pi over 12. If I put that in for theta and multiply it by 3, I get pi over 4. So I purposely kind of took anything unit circle friendly and divided it by 3 to figure out what would be a good plan for this one. Okay, and that's because we're multiplying everything by 3. And then also, so that you can figure out where pi over 18 and pi over 12 and all this stuff goes, a note. Pi over 18 radians, if you convert it to degrees, you could multiply it by 180 degrees over pi radians. Since that's just a version of 1, I know it's been a while, but that's a conversion method, then you could see pretty quickly that you're going to get 10 degrees, okay? So keep that in mind when I start figuring out where pi over 18 goes. It's about 10 degrees. And pi over 9 is 2 pi over 18, so that would be 20 degrees, etc. So I went ahead and before I started the video, I placed, pi over 18, pi over 9. Remember, this is about 10 degrees. This is about 20. 2 pi over, it's pi over 9. Would be about 20 degrees. There we go. Okay. Anyway, so then I went ahead and placed all kind of the weird ones that wouldn't have already been on your graph paper. I went ahead and figured out about where they'd go, and I really just did that by figuring out about how many degrees they measure, okay? So let's go through, and I'll be pretty quick here, but we're going to evaluate R for each of these given theta measures, okay? So put 0 in for theta, triple it, you get 0, sine of 0 is 0, is multiplied by 2, you get 0, all right? So at 0, you are just at the pole. Put pi over 18 in, triple it. Like I said before, you get pi over 6. Take the sine of pi over 6, you get 1/2. Double it, you get 1. So we're facing pi over 18. We're going to go toward it 1 unit. So I'd say that's about like that. Putting pi over 12 in, triple it, you get pi over 4. Take the sine, you get root 2 over 2. Double it, you get root 2. Remember, that is about 1.4. So you're facing pi over 12, you're going to go toward it 1.4. So just a little less than 1.5. Putting pi over 9 in, triple it, you get pi over 3. Take the sine of pi over 3, you get root 3 over 2. Double that, you get root 3, which is about 1.7. So you're facing pi over 9, and you're going to go toward it 1.7. Okay, and at this point, I hope that this is making sense as to how I'm getting these points, but I hope you're also getting excited about another method to do these, but this is part of understanding the other method, so just kind of getting through this. Okay, so triple pi over 6, you get pi over 2, sine of pi over 2 is 1, double it, you get 2. Pi over 6, 2. And I hope it makes sense that since we just ended up taking the sine of pi over 2, which that's the maximum sine value, you're going to see the graph start getting pulled back in toward the pole now. So let's triple 2 pi over 9. You'll get 2 pi over 3. Sine of 2 pi over 3 is root 3 over 2. You're going to double it. You get root 3, which is about 1.7. So you're facing 2 pi over 9. You're going toward it about 1.7. Putting pi over 4 in, you are going to triple it. You get 3 pi over 4. Sine of 3 pi over 4 is root 2 over 2. You're going to double it. You're going to get root 2. So you're going to go toward pi over 4, about 1.4. 5 pi over 18, triple it. You get 5 pi over 6. Sine of 5 pi over 6 is 1/2. Double it. You get 1. So you're going toward 5 pi over 18. Whoops. Toward it. Oh, I missed. Oh, yeah. 5 pi over 18 is a little bit over. There we go. Okay. Put pi over 3 in. 3 times pi over 3 is pi. Sine of pi is 0. Double it, you get 0. Okay? So your graph so far, and we've only gone from 0. Here, I'm going to put little dash lines. This is a technique sometimes we use to show places where your graph got pulled into the pole. So your graph got pulled into the pole at 0 and pi over 3. And as the angle theta increased, your R values, think of it like a connect the dots. Remember those? They were so fun. So it's like a fun little connect the dots. So as theta increased, your R values would grow like so. And then I'm going to put a little arrow to kind of indicate the direction that everything went. Okay, the arrows aren't really part of the graph though. Okay, so that was more detail than we would typically do even with a t-table. So what I'm going to do now is demonstrate how to still use the t-table approach to kind of glean, steal from all the detail that we did over here. But it looks like you're going to get something that looks kind of like the petal of a flower every pi over 3 units. So I'm going to go ahead and mark off from pi over 3 to 2 pi over 3. And then without the same amount of detail, I'm going to go ahead and plot the points. And all I'm going to do, I'm just going to do the angle measures that are already marked here, okay? So if I was to continue this t-table and go from pi over 3, like let's say we jump to 5 pi over 12, okay? So put 5 pi over 12 into the rule, triple it, you'll get 5 pi over 4. Take the sine of 5 pi over 4, you get negative root 2 over 2. Double it, you get negative root 2, which is about negative 1.4. So we are facing 5 pi over 12, but we're going to go away from it 1.4. So follow that line. Can I do it? And then you're going to go away from it about 1.4. Okay, next we're going to put pi over 2 in. Triple it first, you get 3 pi over 2. Take the sine, you get negative 1. Double it, you get negative 2. Okay, so you're facing pi over 2, but you have to go away from it 2 units because the negative R value. Okay, let's put the next point in here, 7 pi over 12. First, let's triple it. You get 7 pi over 4. Take the sine. You get negative root 2 over 2. Double it. You get negative root 2, which is about negative 1.4. So you're facing 7 pi over 12, but you're going to follow that line to the other side and go to negative 1.4. Okay, so Notice I'm just going to put a note here from pi over 3 to 2 pi over 3, we got negative R values. And so your graph would go from 0, it would increase in magnitude, but in a negative way until it kind of maxed out in magnitude at -2 here, and then it would come back in towards 0 when you put like 2 pi over 3 in. I suppose I should demonstrate putting 2 pi over 3 in just to make sure it's complete. But this is kind of, I'll just show arrows to indicate kind of the direction that things would get drawn there. Okay, so just for good measure, let's go ahead and plug in 2 pi over 3 to show that that pedal did get closed out, that you did get a 0 there. So let's triple it. You get 2 pi, sine of 2 pi is 0, and multiply it by 2, you still have 0. So there's that closure of the pedal. And then if we were to go from 2 pi over 3 to pi, remember it's looking like you get what looks like the petal of a flower every pi over 3 units here. If you were to continue in this manner, and now I'm really gonna be cheapskate. Instead of plugging in everything that you see here, I'm actually going to just plug in this 5 pi over 6 value. This is super cheapskate. And then so triple 5 pi over 6, you get 5 pi over 2, which would be around the unit circle and then down it, and then back to pi over 2. So take the sine, you get 1, and then double it, you get 2. So you'd go toward 5 pi over 6, 2 units, and then if you kind of cheat off yourself a little bit and figure it would have continued in the same manner, you would get this third pedal here, and so, like so. So, so there you have it. All right, and it looks like we will stop here and show you a little more information in the next video. Thanks, everybody.